right, everybody, with number 7, I want to go over A2. Now, the formula booklet that I gave you for this assessment had the formula incorrect. The correct formula for infinite series is U1 over 1 minus R. This is the correct one. And actually, the IB has made a version 1.1. And I guess I gave you version 1.0, and it had the incorrect one. But so using the correct one, you should have gotten positive 80. But if you got negative 80, I gave you that correct. But it should have been positive 80. Okay. Now in B, I want to talk about what show that means. Show that means is you are going to find the series formula from the beginning, and this should be your end result. Do not start with the end result and go to the beginning. Start with the beginning and go to the end result. So what I want you to do is I want you to pretend this does not exist. Mark it out, pretend it does not exist. That should be your answer. The reason that they do this is this question might be a little bit difficult, but you'll probably need to use it in C. So they basically give you the answer to 2B so that you can use it in C. Okay, so the series formula, this is arithmetic, so we can use n over 2, 2u1 plus n minus 1 times d. And we don't know what n is, so we're going to leave n as blank the whole time. And the first term is negative 36. And I think we found in the previous problem that d is 4. So now what I'm going to do is now I'm just going to simplify. So Sn equals n over 2 times negative 72 plus 4n minus 4. I'm going to combine my like terms. Sn equals n over 2 times negative 72. Oh, I didn't even combine them. Negative 76 plus 4n. And then I'm going to divide. So I'm going to divide these both by 2. So it's kind of like distributing the 1/2. So I get Sn equals n times negative, negative 38 plus 2n, and I'm going to distribute the n, so I have Sn equals negative 38n plus 2n squared. Now I'm going to erase this part and see if I was correct, and I was correct. Perfect. So this work here is your answers. That's your answers, okay? Okay, and then the last part, okay, C is a little bit difficult. Well, first I'm going to erase all this. One thing to know about IB is usually C and D, like those problems, use things that you did in A and B. It says the sum of the infinite geometric sequence. Well, you found that the sum of the infinite geometric sequence was 80. 80 was the correct answer, but I accepted negative 80. Is equal to twice the sum of the arithmetic sequence. And they just told us the sum of the arithmetic sequence is 2n squared minus 38n. So we take the sum of the infinite geometric series is equal to twice the sum of the arithmetic series. So now we just have an algebraic equation. So let's solve. So I'm going to distribute the 2. And then I'm going to move the 80 over, so I have everything on one side. And look, we have a quadratic equation that we need to solve. So we could either use, I don't know, can we use our calculator on this problem? I don't even know if this is a calculator question. It is a calculator question, so you could use your calculator. You could use the quadratic formula, or you could factor. I'm going to factor because factoring is life. So I'm going to first divide out of 4, and I'm left with n squared minus 19n minus 20 equals 0. Now I have to think of what multiplies to get negative 20 and adds to get negative 19, which would be negative 20 and positive 1. So I have 4. Since n's coefficient is just 1, I can go ahead and set up my parentheses. And so 4 does equals 0 does not make any sense. N minus 20 equals 0 means that n would be 20. And n plus 1 equals 0 means that n would be negative 1. But this n is the term number, and term numbers cannot be negative. So our answer is n equals 20. I hope this helped. Have a wonderful day.